Assalamualaikum warahmatullahi wabarakatuh. So today our group will be presenting about chapter 3, which is application of differentiation. Our group members consist of me, Muhammad Nabil, Muhammad Ikhwan Farhan,
Hi.
Muhammad Iman Danial,
Hi.
and one Nur BALQISH.
Hi.
Without further ado, I will talk about the introduction of differentiation. What is differentiation? Differentiation is a process of finding a function that outputs the rate of change. It also gives us the slope at any point of graph. For linear function, fx equal to ax plus b, a is the slope. For non-linear function, the function fx equal to ax squared, the slope depends on x. Differentiation gives us a function that represents the slope. This is the formula of introduction of differentiation. Next, why we must use differentiation? We must use differentiation to determine the maximum and minimum values. Not just that, differentiation also is a user's function of derivatives.
So we're moving on to our problem statement of our topic, which is a spherical balloon deflated at rate of 10 cm3 per second. Find the rate of change, the surface area when the volume is 32 pi over 3 cm3.
Step 1, we need to extract the information given by the question. So first, we can put the dv over dt. The information given from the equation, which is negative 10 cm3 per second. Why is negative 10? Because it's balloon deflated, so it reduced, so we need to put the negative. So the second one, we need to put the volume. The value of volume given, which is 32 pi over 3 cm3 per second. And last, we need to put the formula of the volume of sphere, which is 4 over 3 pi r cube. Okay, so next we need to find the radius. So we can find the radius based on this volume given. So we can put v equals to 32 pi over 3. So v, we can substitute the formula of volume of sphere, which is 4 over 3 pi r cube. So 4 over 3 pi r cube equals to 32 pi over 3. We can cancel out this pi, and then will become this. Then we substitute the r cube, 4 over 3 into the other side, so will become this. So r cube will become 8. The power of 3 move to the other side will become cube root 8. So r equals to cube root 8. R equals to 2. So we will get the radius is 2. For the step 2, we need to find dA over dt, right? So dA over dt, if we use a chain rule, it will get dA over dr times with dr over dt. We can find dA over dr, but we can't find dr over dt yet. So we need to do another step before we get into this step. So the step is we need to differentiate the volume of sphere. So v equals to 4 over 3 pi r cube. When we differentiate it, it will get 4 pi r square. Why? Because power of 3 is moved to the front, and its power is -1, so you will get square. So the chain rule for dr over dt is dr over dt equals to dr over dv times with dv over dt. So we get the information dv over dt, which is negative 10, and dr over dv, we just to rearrange with 1 over 4 pi r square times with negative 10. We also can put then we can put value of r, which is 2. So 4 pi 2 square, f is negative 10. Then we will get 1 over 16 pi times negative 10. We get negative 10 over 16 pi, and then we can simplify it to negative 5 over 4 8 pi. Sorry.
So we proceed to the next step, which is we insert the area formula for circle, which is A equals to 4 pi r square. And then we derive it into dA over dr equals to 8 pi r, because we bring the square into the front and we minus it with 1. And then we can make a chain rule, which is dA over dt equals to dA over dr times with dr over dt, right? And then as we can see that dA over dr is equal to 8 pi r times dr over dt, which is negative 5 over 8 pi, and we can cancel out this 8 pi, equals to r times negative 5, and we know that r is radius, and radius equals to 2 times with negative 5, and it's equal to negative 10 centimeter cube over time. It's dA over dt. Thank you.
So lastly, we can conclude that differentiation has many applications, such as to detect the gradients. Other than that, it also provides a measure of the rate of change at given moment. In a nutshell, calculus is very useful in solving problems of the real life form where values must be maximized or reduced.
So that's all from us. Thank you. Bye bye.
Bye.
Bye.